Hello everyone and welcome to your first video lesson of the year. This is lesson 1-1. The first one means chapter 1 and the second one is lesson 1. So this is chapter 1, lesson 1. Factors and multiples. Please be sure to write down the title and today's date when I say the title. So factors and multiples. Today we are going to learn about the greatest common factor and the least common multiple. In order for us to learn what these words are and how we use them, we have to look at what they mean. A common factor is a number that is a factor of two or more numbers. The greatest of the common factors are two or more numbers is called the greatest common factor. Now this probably does not mean a lot to you, but for example, if I say, what is 3 times 2? Well, 3 times 2, what I'm saying is that it's 3, how many times? 2 times, right? So it's 3 one time and another time. So 3 and 3, right? 3 times 2 is 6. Okay? We call these numbers factors. These are called factors. Numbers that multiply into each other are called factors. And then the number they create together is called a product. The way I like to think of it is that factories make products, right? Any product that we need to buy, that we go to the store, to Walmart or anywhere, all those products are made in factories. And that helps me remember that factors create a product. So when we look for a greatest common factor, we're looking for these numbers that create the product. The least non-zero number that is a multiple of 2 or more whole numbers is the least common multiple, LCM, of the numbers. When we talk about multiples, we're saying, for example, some of you know how to count by multiples of 3. The first multiple of 3 is 3. That's the first one. And then another 3 would be 6, right? And then if I add another 3, 9, and another one, 12, and another one, 15, and so on. These are multiples. Here I am counting by multiples of 3. Okay, so I may give you a number, for example, like the number 4, and I may give you the number 3. And I could ask you, what is the least common multiple of these two numbers? What you're going to do is you're going to count by multiples of 4. What's the next multiple? 8, correct? Then the next one? 12. Each time it's going up by 4, is it not? Right? If I tell you to count by multiples of 3, the first one you'll say is 3, then 6, then 9, then 12. Notice how they both have 12? And that is the lowest number that they both have in common when you count by their own number. When you count by 4s, you will get to 12. When you count by 3s, you will get to 12. This is the first number these two numbers have in common. So this is what we call the least common multiple, or LCM. Okay, so in your notebooks, in your workbooks, let's go ahead and fill this out. What is the greatest common factor? What is the GCF? Stands for the greatest common factor. And what does the LCM stand for? The least common multiple. So what is the define? Let's define greatest. Greatest means what? Usually it means the most, right? The greatest, the highest, the most. Common means alike, correct? Alike. What two things have alike? And factor are numbers multiplied, right? Numbers that are multiplied. Numbers multiplied. Multiplied. Oh, sorry for the mess. What is on the other side, what does the least stand for? The least means the lowest, like the lowest value. Common, again, alike. All right, and multiple. We usually learn about multiples when we say skip counting, right? When you count by 2s, count by 3s, count by 4s, and so on. Skip counting. And there you go. So let's see how we could use this in a real world problem. Brian is making balloon arrangements. He has 8 blue balloons and 12 green balloons. What is the greatest amount of arrangements he can make if he wants them to be identical? So arrangements means he's going to put them together into groups, right? You can see here he's got a big green balloon right there. But he wants them to look the same. So what do? Well, we see that we have 8 blues and 12 greens. We have to look at the factors. What numbers multiply make up 8, and what numbers multiply together make up 12? Well, I can make, for example, or what common multiple do both of these have? You see, in 8 and 12, how many 4s do I have in 8? It's 4 plus 4, correct? And then how many do I have in 12? I have 4 plus 4 plus 4. So that means that I could have in each arrangement, I could have 2 blues and 3 greens, because the greatest common factor for these two numbers is 4, right? I can make 4 arrangements where I have 2 blues and 3 greens. So one arrangement would look like this, and it's 5 balloons in total, right? And I said I could have 4 of these. 4 times 5 is 20. 8 plus 12 is 20. So it would work. Okay, so the main objective of this lesson is for you to find common factors or prime factors to find the greatest common factor. We're going to use what we call a prime factorization tree. And we're going to make a factor tree. At this point, I would like you to look at this example, example 1. Please read through it and look at how it's been solved. Okay, take a look at the table here on the right. For the sake of time, you please pause the video now and read through it. And then watch me do the following question that is similar to this. For the following question, right here, you will have to actually copy this down in your notebooks as well and do it as I do it. But in the meantime, as I mentioned, pause the video and read this question, and then play to see how the next question is solved. Question A. Lana earned $49 on Friday, $42 on Saturday, and $21 on Sunday selling bracelets. She sold each bracelet for the same amount. What is the most she could have charged for each bracelet? So we're looking for the most. This sounds like the greatest. We're looking for a number that when you multiply gives you 49. When you multiply that number by another number again, it gives you 42. And that same number, when it's multiplied, gives you 21, right? So we're looking for a common factor, and we want the greatest common factor. When I look at 49, I know that 49 is a factor of 7, right? If 7 times 7 is 49. When I look at 42, I also see that 7 is a factor. 7 times 6. And 21. 7 times 3, correct? So I see 7 when I see these three numbers. These are all products of the multiplication table of 7s. But I mean, that's just me because I'm very familiar with multiplication. But here's how you could do it. You could write 49, and then what two numbers make up 49? 7 times 7, right? You could write 42. What two numbers make up 42? There's multiple numbers that make up 42. Right, there is 3 times 14, 2 times 21, and so on. Let's say I wrote 2 times 21, right? I can't break the 2 down anymore, but I can break the 21 down, right? And I can break that down into 3 times 7, correct? And then 21, what makes up 21? I know that 3 times 7, as I just did in the previous one. So which one is the greatest factor? Well, I see that there's 7 here, there's a 7 here, and there's a 7 here. So what could she have charged for each bracelet? What is the most she could have charged? $7. So on this day, on Friday, she sold 7 bracelets. The 7 bracelets at $7 is $49. On how many? On Saturday she would have sold 6 because 7 times 6 is 42. And on Sunday she sold 3 because 7 times 3 is 21. So $7. Therefore, these 3 dots mean therefore. The most she could have charged for the bracelets is $7. Make sure that you copy down the factor trees I made and the therefore statement, because this is a word question. We answered it with words. And here you have another example of how a prime factorization tree or prime tree was used. Please take a look through it. You can see that what 2 numbers make up 12? 6 times 2. 2 is a prime number, so we can't break that down anymore, so we just bring it down to 2. But what makes up 6? 3 and 2. Those are the other 2 prime numbers. A prime number is a number that is only divisible by itself, by 1 or itself. So we can't divide it any further. It has no other factors. So the greatest common factor, so what do you do with these prime factors? Only the common ones. You multiply them to each other. 3 times 2, 6. And 3 times 2 is 6. So what is the greatest common factor for 12 and 18? For 12 and 18 is 6. So let's do it here. If you think you know how to do it already, I encourage you to pause the video now and try these on your own, and then play the video to check your answer. Pause now. Okay, if you didn't pause the video and you're just watching right through, that's fine too. Now let's check how to do these. So we have 12. I take 12, I write it here, and I have 66, correct? Okay, for 12, what 2 numbers make up 12 that I know of? I could do 3 times 4, yeah. 3 is a prime number, so I'm not going to break up the 3 anymore, but 4 is 2 times 2. If you want to check, you just multiply these 3 numbers together. 3 times 2 is 6, and 6 times 2 is 12. There it is, yeah. 66, let's see. For 66, I have 2 times 33, I could say. And then I could do 3 times 11, right? 2 times 3 is 6, and 6 times 11 is 66. Yep, that works. Okay, so now we just take the numbers that they have in common. Which numbers do they have in common? Do I have a 3 here? Yes. Do I have a 3 here? Yes. Do I have a 2 here? Yes. Do I have a 2 here? Yes. This 2 is extra, and this is extra. So then when I multiply 3 times 2, I get 6. Oops. Made that too big. And then again, 3 right here, or 2 times 3 is also 6. So what is my greatest common factor for 12 and 66? It is 6. There's my answer. So my GCF, greatest common factor, right here, greatest common factor, GCF equals 6. Okay, let's try the same with 18 and 30. Factors of 18. What 2 numbers multiply to make 18? I have a 3 and a 6, correct? And then I have a 2 and a 3. You see that? 3 times 6 is 18. I have 6. This is a prime number. I can't break it down anymore, but 6. 2 times 3. Good. All right, for 30. I have 3 times 10 is 30. Break up the 10 a little bit more. 2 and 5. And there's my prime numbers. Okay, what prime numbers do I have in common? I have a 3 here and a 3 here. 2 here and a 2 here. This is extra and this is extra. So again, it looks like my greatest common factor is 3 times 2 is 6, and 3 times 2 is 6. Again, my GCF is 6. Okay. Let's try D. Okay, I have 32 and 48. 32, looks like I have 2 times 16, right? That gives me 32, and then 16 can be broken down into 2 times 8, and then this can be broken down into 2 times 4. Oh, it keeps going. And it can be broken down into 2 times 2. Well, that's a lot of 2's, right? And over here I have 2 times 24, 2 times 12, 2 times 6, and 2 times 3. How many 2's do we have in total on each side? I have 1 here, 1 here. 1 and 1, 1 and 1, 1 and 1. And then this is extra because it doesn't match there. So what is 2 times 2? 4 times 2? 8 times 2? 12. Oh, did I do that wrong? I sure did. Let's do that again. 2 times 2 is 4, times 2 is 8, times 2 is 16. 16. And over here, 2 times 2 is 4, 4 times 2 is 8, and 8 times 2 is 16. And there we go. And so the greatest common factor for 32 and 48 is 16. And that makes sense, because 16 times 2 is 32, and 16 times 3 is 48. Okay, now that we're familiar with factors, let's try working with multiples. Multiples is counting or skip counting. You can find the least common multiple of two numbers by using a number line, making a list, or by using prime factors. Again, please, I encourage you to pause the video now and take a look at this example, example 3, on how a number line is used to find the least common multiple. Or method 2, using the multiples to find, as you can see, listing them off. So please pause the video now and see what you gather from this, and then watch me do the examples. The same goes for 4. In 4, they look for the least common multiple of 14 and 21 using prime factorization. That's what we were just doing. We were doing the prime factorization, the prime trees. So go ahead and take a look at that. Now, let's do E, F, and G. Okay, let's try the example for E, 2 and 6. 2 and 6, counting by 2's. Let's just count, go ahead and just count. 2, 4, 6, 8, 10. I'll stop there. Let's count by 6. 6, 12. Oh, right away I can tell that my first multiple when counting by 6 is 6, which I've already counted in the 2. So you can see that that is a like multiple of the 2. When you skip counting by that number, that's a like multiple. So, and that's the least one, because there's no 4 or 2 here on this column, right? No 2 or 4. So it's 6, the first one. LCM, least common multiple, is 6. All right, let's try here. 4, 8, 12. Counting by 4s, by the way. 16, 20. I'll stop there, because I know that numbers, when counting by 5s or counting by 10s, the numbers are going to end, some of their multiples are going to end in 0, and this one just ended in 0. So 5, 10, 15, 20. There it is. And then counting by 10s, 10, 20. Again, there it is. All three have 20 as a multiple. Now these two have 10, but unfortunately 4 does not have 10 as one of its multiple. So 10 cannot be it. It has to be 20. Our LCM is 20. Okay, and now let's try here. Again, we can try just by counting by the numbers. 3, 6, 9, 12, 15, 18, 21, 24. This one goes on for a while, because I can see that by counting my 5s, the only number that I'm going to have when I count by 5 will be 15. But when I count by 7, I will not have 15. I will have 21, but counting by 5s, I will not have 21. So what's a better way to do it? Well, knowing that all these numbers are prime numbers, I could just simply multiply all three into one another. 3 times 5 times 7. Let's see, 3 times 5 is 15. Times 7. Okay. Well, in case you don't know how to do it, you take the 15 times 7. And we have 7 times 5, 35, carry the 3. 7 times 1, 7, plus 3 is 10, so it's 105. So I would get 105. And when counting by 3s, and counting by 5s, and counting by 7s, the first number that they will all three have together will be 105. For example 5, you will see a real-world example. Again, please pause and read through it. If you have any questions, please feel free to ask me in class. And we will begin our next class by completing the guided practice together. I will project this image on the board, and we will complete all of these questions together. Please take a look at them now, and if you don't understand how to do these questions, go back to examples 1 and 2, or examples 3 and 4 for these ones. And that will help you be better prepared for the beginning of next class. See you then, everyone.